Today we'll be talking about counting principles. So when we refer to the fundamental counting principle, here's what we are talking about. This is the number of ways in which a series of successive things can occur by multiplying the number of ways in which each thing can occur. Okay, so what that means, if we look at our first example, we're at Payway, and we have a choice of 8 different entrees, 4 different sides, 10 different drinks, and 3 different desserts. How many different dinners consisting of 1 side, 1 entree, 1 drink, and 1 dessert can you choose? Well, we have 8 entrees to choose from, 4 sides, 10 drinks, and 3 desserts. And so I can find the number of ways I can have a different dinner if I select one of each part of the meal. And when we multiply all this together, we have 960 different meals. Let's look at another one. The standard configuration for a Nebraska license plate is 3 letters followed by 3 digits. How many different license plates are possible if digits and letters can be repeated? So we're thinking we have 3 digits and 3 letters. Okay, so we know these are digits, these are letters. We know digits, you have 0 through 9, so that would be 10 digits, and if they repeat, I'm going to multiply by 10 for the remaining of the digits. And we have 3 letters, and we multiply all that together, and we do have 17,576,000. How many different license plates are possible if digits and letters cannot be repeated? So again, we have 3 letters followed by 3 digits. And we know A through Z, there's 26 letters, and if I've used 1 letter, there are 25 remaining letters, then 24. For digits, we have 10 to choose from first, and then we have 9, then 8. And when we multiply these numbers together, it is only 11,232,000. Take a minute and try this example you try. Hopefully you found your answer to be 4 to the 10th power, or 1,048,576 different ways to complete the test. In our next example, in how many ways can a 6-question true-false question be answered for quiz? So we have 6 questions, and how many different ways can we answer it? Well, how many choices do you have per question? Well, you have true or you have false. So each question, there are 2 choices. And this gives us 2 to the 6th power, which in this case is just 64 different ways. And I want you to take a minute and try the example you try. And we are assuming that we can have numbers repeat, so 125,000. So when we start referring to permutations, these are used to determine the number of ways that n elements can be arranged in order, meaning it's an ordering of n elements. Okay? If you have homework assignments from 5 different classes to complete this weekend, in how many ways can you complete the assignments? So we know we have 5 different classes, and we have homework in all 5. So let's see, 5, then 4 left, then 3 left, then 2 left, which is the same as 5 factorial, which is 120 different ways. And how many different ways can you choose 2 of the assignments to complete first and last? So we still have our 5 homework. Now to choose first and last, to do first, we would have 5, and then last, we would have 4 left to choose from. So this one would be 20. And if I wanted to find the number of distinguishable permutations of the letters of the word, the first thing we're going to do is we got to figure out how many letters there are in the word. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial over. Now, how many of those words or letters repeat? Right? Because it's like I'm cutting up the letters and it's almost like they're Scrabble tiles and I'm putting them in a bucket and mixing it around and drawing out a letter. So any letters that repeat is going to change the number of different ways I can arrange the letters. So notice we have an S, so that would be our 2 factorial. And then notice we have T, we have 1T, 2T, that would be 2 factorial. And we have, oh my goodness gracious, look, we have 3 S's, whoopsies. And then we have 3 T's actually. And then we have 2 I's. Okay, and that is 2 factorial. Okay, so these are my number of I's, these are my number of T's, and these are my number of S's, and that's a 3, by the way. And when we type this in, we could expand it if we wanted to. And 3 factorials cancel. We know 3 times 2 is 6. 2 goes into 4 twice. And then when we multiply, we do get 50,400. I want you to take a minute and try the 2 example U-tries. So hopefully for A for Nebraska, you have 20,160, and for letter B, chocolate, 90,720. Now, if we wanted to look at a specific formula in which order it does distinctly matter, we can do permutations of n elements taken r at a time. So the number of permutations of n elements taken r at a time, we use this formula NPR, which the calculator will also do. You would type in the first number, and then, for example, if you had like, let me go to the pencil. Let's say you had 5p2, right? So you would have 5 factorial over 5 minus 2 factorial. And if to type that in the calculator, you would push the 5 first. Then you would find the math button. You're going to highlight probability. And then you would, I think it's option 2, NPR. And then you would type in 2 and then push enter. And that's it. I typically will just draw the blanks and not really use NPR in practice. So there are 12 books on the AP summer reading list, and you want to read some or all of them. How many ways can you read 4 of the books? So I know I'm only going to read 4 books, and we have 12 to choose from. If I've read one book, there are 11 left. If I've read one, there's 10 left, and if I've read one other one, there's only 9. For a total of 11,880. And then if we look at all the books, that's just 12 factorial. And let's see, 479,001,600. Try these last example U-tries. So hopefully for A, you found 840, and for B, you have 8 puppies altogether in the numerator, and you have 3 repeats for males and 5 repeats for females, for a total of different birth orders of 56. The end.